Welcome everyone to this tutorial. So today we're going to talk about probability, what it is, and I'll be using some examples to illustrate how we calculate it. Let's get started. In simple terms, probability is a value that tells us about the likelihood of an event occurring. And we can make use of what is called a line of probability to visually represent this. On the left-hand side extreme of this line, we have events that are very unlikely. On the other extreme, we have events that are certain. Number allows us to precisely express the degree to which an event is likely to occur or not. So 0 represents an event that cannot occur, whereas 1 represents an event that always occurs. The middle then, represented by 1/2, means that an event is as likely to occur as it is not to occur. So generally speaking, any probability values that fall on the left-hand side of this probability line indicate that a particular event is unlikely, and a probability value on the right-hand side would indicate that an event is likely. Besides fractions, probability values are usually represented both in decimals and also in terms of percentage. So in general terms, whenever the weather forecast tells us that there is a chance of rain greater than 50%, we might want to take the umbrella with us. Now let's dive into how we calculate probability with a simple example. For this we need a genuine regular coin, that is, a coin with two different sides and equally distributed way. And then we would ask, what is the probability that a coin will show heads when we toss it into the air? We know that a coin has heads on one side and tails on the other, which we are going to refer to from now on as the letter H and T respectively. We ask probability questions when there is certain degree of uncertainty about an event or something happening. In this example, we don't know what side the coin will show once we toss it into the air, but probability theory gives us a way to describe the chances of the coin landing on one side or the other based on some of the available information, such as how many possible outcomes there might be. In our case, we know, for example, that a coin has only two sides, so that's the total of a number of possible outcomes. And what particular event is it that we are interested in taking place? In our case, we're interested in getting heads. In mathematical terms, we would ask then how many equally likely possibilities are there? This is also known as the sample space. In our case, since a coin only has two sides, there are only two possible outcomes. The next question is, of those possibilities, how many meet our specifications or conditions? Mathematically, we write P, which stands for probability, and in between brackets some arbitrary reference to the event whose probability we want to calculate. In other words, the event that meets our condition. Usually letters in alphabetical order are used, such as A, B, C, but in this case we'll use the letter H since it serves our purpose as we are clearly interested in finding out the probability of obtaining heads. So in one toss of the coin we would have only one heads, and we divide that by the total of equally likely possibilities, which is 2, also referred to as sample space. In this case, it would correspond to the sides of one coin. And we would get a probability of 0.5, which, if we expressed the result in percentage, that would be 50%. This means that a coin is equally likely to land on heads or tails. If we were to repeat this experiment several times, the estimated probability of getting heads would remain the same. Of course, if you do this 10 times, there is a chance that we would have an uneven number of heads and tails. But as we increase the number of observations and we do this more and more, the more we try it, the more equal that number of heads and tails will become, approaching the estimated probability of 0.5. Another typical example that helps us understand some of the basic concepts of probability is the case of rolling a dice. We know that a dice has 6 sides, so our sample space is going to be each of the sides. And let's say that we are interested in the probability of obtaining a number 4. So applying our probability formula, we have 6 equally likely possibilities, 1, 2, 3, 4, 5, 6, and of those, only one corresponds to our condition, which is that of obtaining a number 4. We could add more conditions. So for example, we could ask, what is the probability of obtaining a 4 or a 6? And that means that we now have 2 as our numerator, so there'll be a 1/3 probability of getting a 4 or a 6 when we roll a dice. Bear in mind that on one roll of the dice we could only get one of these 2 possible conditions, which is why we use the logical expression OR. If we were to ask what is the probability of obtaining 4 and 6, well, given the fact that we only have one roll of the dice, and as explained earlier, our denominator consists of equally likely possible occurrences of a phenomenon, the estimated probability here would be 0. And as we cannot get to numbers on one instance when rolling one die, this would be impossible. This is usually referred to as mutually exclusive events. Take a moment now to think about the probability of obtaining an even number when rolling a dice. So feel free to pause the video at any moment. So the fact that this represents half of our sample space, as in the case of the coin, we might already have an idea about the probability of obtaining an even number. Alternatively, we could expand the number of possibilities by adding an extra dice. So one dice is represented by the letter A and the other one by the letter B. So we could ask, what is the probability of obtaining a number 4? However, since we have 2 dice, our sample space consists of all the possible outcomes coming from both dice, which means that for each outcome of A, there are 6 possibilities for B. So the total number of outcomes, A and B, is 6 times 6, which is 36. This would also be known as an example of the multiplication principle. Okay, this matrix shows all the possible permutations or outcomes from rolling 2 dice. We have 36 pairs of numbers, where each number within the square brackets represents the number shown by a dice. So let's try to identify the different ways in which we could obtain a result of 4. Feel free to pause the video and try to find them. And we have 3 possible ways in which we could obtain an outcome of 4, highlighted here in green. How about obtaining a number 6? And again, the pairs highlighted in purple gives us the answer. But the interesting thing is that since all of these possible outcomes constitute our sample space, we can then go back to the previous probability problem and ask, what is the probability of getting a 4 and a number 6? And since both possible outcomes are independent, as we can notice by the 2 separate sets of pairs in green and purple, we can just add these possible events. Lastly, let's look at a case in which our sets are not independent. So here we have a map of the UK, with each of its 4 nations distinguished by their respective flags. Now let's assume that we have sent out a questionnaire and we have information from 8 Scottish individuals, 9 people from Northern Ireland, 5 from Wales, and 7 from England. Now let's suppose that we arbitrarily classified people based on whether they belong to a nation with blue or red in their flags. So Scottish and Welsh are grouped as blues, and Irish and English are grouped as reds. But let's say that we also classified people depending on whether their nation is on the north side of the island or the south. So we'll have 13 for the north and 12 people for the south, grouped in those terms. So we now have a total set of 29. And let's say that we take all the people with blue in their flags, that means Scottish and Welsh. So we would say that the probability of B, which stands for blue, is equal to 13 divided by 29. And on the other hand, we take people grouped as being from the south, represented by the letter S. So we have both Welsh and English people. We can see in this Venn diagram that there is some overlap, specifically Welsh people belonging to both groups. And the probability of drawing somebody from this sample that is from both the south, from the south and a nation with blue in the flags would be 5/29. Now let's assume that we need to select somebody from our sample, but we are only interested in people who are either from the south or whose respective nations have blue in their flags. We could then ask, what is the probability of S or B? The sample is the same, so our denominator is 29. And we have 12 people from the south plus 13 people with blue flags minus 5. Now, since Welsh people in our sample belong to both groups, and they were already included when counting all people classified as from the south, we have to subtract this number. Otherwise, we would be counting them twice. This means we are excluding 7 people who are from the south but do not have blue in their national flags, and 8 people with blue in their flags but who are from the north. In this case, there is a 70% probability of picking somebody who meets our specifications. Alternatively, we can express this probability as the probability of S plus probability of B minus the probability of S and B, all of those computed independently. And this is another case of what is known as the addition rules of probability, along with the previous example in which we did not need to subtract anything, since, unlike in this case, we dealt with independent sets of events. Thank you everyone for watching this video. So today we covered some basic concepts about probability, and we saw how we can calculate it by using a simple formula. We also covered some key concepts such as how to visually represent how likely or unlikely events are using the line of probability, what is an event, what constitutes our sample space, or the number of possible events that we can actually calculate probabilistically. And we saw some key concepts or scenarios where we have events that are mutually exclusive and cannot happen at the same time, as well as occasions in which the number of possible events can be combined, or when they cannot be combined, as in the case of the addition rule of probability. That's it for today, and I'll put a link to a video where you can see how sometimes probability is also introduced along other statistical concepts, especially in social sciences. Bye.